Welcome to the recording of CSC101, an introduction to C#. Now, this is the first C# class in the C# track, and because of that, we're going to focus on some prerequisites. We're going to first talk about the actual role of how Xamarin and C# work together. We'll talk about some history in programming. Then we'll move on to actually building our first console C# application. And then finally, we'll finish the class looking at the fundamentals of C#, basically looking at some of the basic C# constructs. We'll look at some basic operators and basic syntax. So in this first objective, we're going to look at defining programming, and we'll look at how C# and Xamarin work together. So to do that, we have three main tasks. We're going to define some of the common terms that you may hear when talking to a programmer. We'll look at some history of C#, what got us to where we are now, and then we'll talk about why C# fits into this mobile landscape. So let's begin with a term, and the term is programmer. What does it mean to be a programmer? And really simply put, a programmer is someone who writes software. Now, there are other terms you may hear as well, terms like developer, engineer, possibly a hacker. These are all people that write software. Now, programmers use programming languages to tell the computer what we want to do. So a program language is just a way that we can give instructions to our computer. And what's interesting with C# is that C# is considered to be somewhat of a high-level language, which means that it's not too difficult to understand. For example, even though you may not know C# right now, you could possibly look at this code right here and maybe figure out what's going on. So this is a valid C# program, and without knowing too much, we can see the basic flow. So we have a number 3 and 5, and it looks like these are represented as x and y. And we're just saying, if x is greater than y, do something, right? So using some common sense, we can say, well, if 3 is greater than 5, then we're saying the maximum or the greater number of the two is x, else the greater is y. So this is a basic program to just figure out what is greater, x or y. Now, when we create a program, the whole point of the program is to execute on a computer. And the CPU, or central processing unit, is what's responsible for executing your program's instructions. Now, CPUs understand what we call binary. Or if you look back, it's also considered high and low voltages, basically electricity flowing or not flowing. So if a CPU only understands binary ones and zeros, how does it understand our program that we write in basically English? And the truth of the matter is that it can't understand that. It can't understand our high-level language. It can only understand a low-level language like binary. So the way that we solve that problem is with the addition of a compiler. A compiler's job is to take our program, so in this case our C# program, and compile it into something that can be understood by the CPU. Now I'm going to stop here for just a second because these slides are a little bit misleading for C# specifically. The default behavior of C# doesn't traditionally follow this flow. There is another step involved, but we're not going to get too much into that. Just note that this is the traditional concept. We have a programming language, we compile into something the computer can understand. When it comes to actually writing this software or writing this code, we need to use an IDE, or an integrated development environment. And there are two common ones that we can use. We have Visual Studio for Windows or Visual Studio for Mac. Now, that's what I said is not technically true, right? You can build programs not using an IDE. You could, for example, open up Notepad, write your code in there, and use a compiler to compile it. It's just not too common to do that. So as a new programmer, it's definitely recommended to grab an IDE like Visual Studio and use that. Now here's just a quick timeline showing where we are and how we got to C#7, which is the current version of C#. So you can kind of follow the timeline. We have C, then we have C++ and Objective-C, where they introduced a concept called object-oriented programming. Then we have Java. Java is a very similar language, very similar syntax to C#. And then after that, we have the versions of C#, and you can see the years. So currently we are on C#7, which was released in 2017. So I want to switch gears just for a second and talk about mobile programming. Now, when it comes to mobile programming, traditionally we build for the separate platforms using languages that are native to that platform. For example, when we build an Android application, we traditionally use Java. When we build an iOS application, we traditionally use Objective-C or Swift. And when we build some type of Windows application, we traditionally use C#. Now, if you think about this, that means that we are writing the same application 3 different times using 3 different languages if we want to target each platform. Even if you only want to target maybe 2 platforms, you're still writing it 2 times in 2 different languages. So this is really where C# and Xamarin shine. Xamarin enables you to build cross-platform applications, so iOS, Android, and Windows applications using C#. And because we're using C# for all 3 platforms, we can share the code across those platforms. So this is very powerful. It can save us a lot of time, and you'll learn a lot more about this throughout taking classes at Xamarin University. Alright, so far we looked at some basic terms like compiler, programmer. We looked at some quick history on what version of C# we're currently using, and we briefly talked about what makes Xamarin so compelling to use as a mobile solution. Now let's take some of the concepts that we just talked about and let's try to put them together to build our first C# program. So we're going to get started talking about setting up our environment, and then we'll look at building our first Hello World application. So when we create software, we tend to move through different phases. So the first phase is design time. This is where we're actually writing C# code to build our application. So this will consist of logic that starts the application, that displays a login screen, whatever it is, this is what we're writing to build our software. Then we move to compile time. And this is where we actually compile the application into something that the computer can understand. This will also be used to find problems with our program, because if there is a problem, we can't successfully compile and we'll be notified about it at that point. And then finally we have runtime, and this is where we actually run the application, whether it's on a computer or a mobile device, whatever it is, we're running and we're testing it to make sure we see it's doing the correct thing that we told it to do. And this process never ends. We continue to repeat steps 1, 2, and 3 over and over again until the application is done. So throughout the C# track, we're going to be focusing on building console applications. And the reason why we're going to do that is because console applications are very easy to print text to the screen and receive input from the user through the keyboard. This makes it very easy to focus on the C# language and learn the fundamentals and not have to worry about other libraries and SDKs that aren't a part of core C#. So let's begin with the simplest operation to display some text to the user, and that is console.writeLine. So there's a couple important things that we have to point out here. So console is a class. That's why it's in that blue color. We'll learn more about that in upcoming courses. And writeLine, that is a method. A method is an action. And if you think about it, displaying text to the user is an action. Now, inside the parentheses here, so this section right here, this is what we're trying to print to the screen. Now, you can see that the text that we're typing is inside double quotes. That is important for this example. This is indicating that this is a string, which is a piece of text we're trying to display in this case. So as you can see, whatever we put into that will be printed onto the screen. So when you create your new project and you open it up, you may be a little intimidated because there are quite a few different pieces. So let's focus on the right-hand side for now. So this is a Visual Studio. This is a brand new console application. We open it up. The first thing we have is the solution. Now, the solution is basically a container for projects. If we were building, let's say, a mobile application to deal with car maintenance, we may have an iOS version, an Android version, and a Windows version. Those would all be coupled inside of our solution for the application. Now, each of those platforms would then be their own project. So you would have an iOS application project, an Android application project. Maybe if you had a console application, right, that would be a console application project. And then inside the project, it contains source files. This is the actual C# code that makes up your application. And inside of a source file, you have the source code. And these are the actual C# statements that are your program. All right. So what I want to do now is I want to jump into Visual Studio, and I want you to build your first Hello World application. So let's switch over to Visual Studio. All right, so here we are in Visual Studio, and let's go ahead and create a new console application. So we're going to go up to the File menu, go to File, New, Project. Now this is going to load a bunch of different templates. Now we want to go under Visual C#, and then we want to find the console application for .NET Framework. So go ahead and select that. Then you can come down here and you can give it a name. I'm going to call mine Hello XAMU. You can pick a directory where you want to save it and then click OK. Now this is going to go off. This is going to create a new console application. It's creating all the required files. So this is going to consist of what we call the main method. So before we get into writing the code, let me just point out a couple of things that the slides did not. So first, you can see when we create the project, we have the solution, project, and source file. So this program.cs, that's what we're currently in right now. Now, another thing that I want to point out is this class. So the file is called program.cs, so is the class. It's called class program. This is a common thing that you'll see, and in the third class, we'll talk about what classes are. But for now, the most important thing for you to understand is this guy. This is called the main method. The main method is the entry point for your application. So when you double click on that executable file to run the application, this is the first place the code starts executing, right here. So anything in between these two curly braces will be considered a part of the main method. Now our goal for this first exercise is to print a simple hello message to the console. So I want to start off with the traditional Hello World application every programmer goes through that. So to do that, we're going to do what we saw in the slides. We're going to type console dot write line. In parentheses, we're going to put a string. So we're going to say console.writeLine, hello world, close your quote, close your parenthesis, and every statement in C# ends with a semicolon. That basically says this is the end of the statement. Now, if you're on a Windows computer, to run this, you want to hit Control F5 or go to Debug, Start Without Debugging. Once again, we'll talk more about this throughout the C# classes as well, but for now, you would do that. Now, if you're using Mac with Visual Studio, you can just hit the big play button that you see. So I'm going to go ahead and hit Control F5. This is going to compile my program to make sure the syntax is correct and everything else, and then run the application. And when we do that, this is the output. It says hello world to our console. Pretty cool. Now, just to finish up this exercise, know this is very simple. We're going to change the message to hello Xamarin University. Just for the fun of it, let's run it again. And there you can see our new output. Hello Xamarin University. So in this last objective, we looked at creating our first Hello World application. And in that, we looked at some other things like the solution, the projects, the source files, to have a better understanding at what it is to build an application. So in this last section, we're going to get a little bit deeper with C# and look at some of the fundamentals of the C# language. We'll talk about what C# statements are. We'll look at different data types. We'll look at creating variables and constants. And then we'll look at things like strings and white space. So some of the basic building blocks of programming. So to get us started, let's talk about statements. So in C#, a statement is traditionally ended with a semicolon. It doesn't always have to be that way, but for the most part, you'll see that. And a statement is simply a single instruction for our computer. So you can see some statements here, and we'll talk about exactly what those are in just a second. You can see that some statements can span multiple lines, like this. And finally, there's an example of a statement that we've already have seen and programmed, which is console.writeLine. Now, another thing that you'll come into contact often with is comments. And comments are just notes that we can leave in our source code so that other programmers or even yourself can quickly determine what a piece of code is doing. Because believe it or not, you will eventually write code, come back to it maybe in a week or a month, and you'll be like, wait a second, what is this code doing? And it will happen, trust me on that. So we use comments to document our code to make it easier to remember what exactly it's doing. And there are different types of comments. We have single line comments, which are created by 2 slashes. And a single line comment just simply comments out the code or the text on that line. Whereas a multi-line or a block comment can span multiple lines. And the way that you create that is you have an opening set, which is a /*, and a closing one, which is a */. And everything in between that will be a comment, and it will be ignored by the compiler. And finally, you can nest comments as well. This is common to see when you have a single line comment and then you use a multi-line comment to just comment out a large piece of code that has that single line comment. So getting into C# a little bit more, let's talk about what a type is. So a type is what defines what kind of data we are working with. for example, let's say we're working with numbers, more specifically whole numbers. That type we could use is an integer. Let's say we were dealing with text. That type we would use is a string. And let's say we wanted to display a button on our screen. That type would be a button. So a data type or type defines what type of data we have. Now, types go hand in hand with variables. So a variable is simply a named storage container. It's a place that we can store data that has a name, and the type of data that can go inside of it has to be that data type. So the syntax for creating a variable consists of, first, the data type. So what type of data this variable can store. Then it consists of the name of the variable. The reason why we have to give it a name is because a variable is really stored in memory. And if we didn't have a name, we would have to access that variable by the memory address. And that's really hard to remember, so we associate names to make it easier for us to access that memory location. And then we have a value. So the value is what's going to be dumped into that variable. And the thing that is assigning it is what we call the assignment operator. That's that equal sign. You can think of the assignment operator as saying whatever is on the right-hand side is going to be put into whatever's on the left-hand side. So the value 25 is going to be stored into the variable called age. Now, when you do this assignment at the same time of creating the variable, that's called initialization, and that's optional. If you wanted to, you could have just said int age semicolon and skipped the value itself, and at a later point you could have came back and gave it a value, because variables can change over time. They aren't constant. Now C# actually has a lot of built-in data types that we can work with. We have data types that deal with text, that deal with date and time and numbers and true and false values. There's data types for tons of operations built into the C# language. Just kind of exploring some of them, let's start with some numeric types. So here we have some basic numeric types. The most common that you will use are int and double. Integers are used to store whole numbers, whereas doubles are there to hold fractional or decimal numbers. And you may be wondering, well, why are there so many other data types? What is float, short, U short, long? And there is a large list of them. And the answer to that is really it's memory. You know, back when computers were not as strong and didn't have as much memory, we wanted to make sure we didn't waste any memory. So, for example, if we were building a program and we wanted the user to enter a number, but we knew the number was always going to be between 1 and 10. If we used an integer for that, we're actually wasting memory because an integer can hold a number that is up to about 2 billion. So all that extra space is being wasted. Whereas there are other data types like short or byte that hold whole numbers as well, but they can't hold as big of a number, and you would use that to save some memory. Now, granted, in today's age, RAM is so easy to get and very cheap that we don't really consider it a problem anymore. We really don't even consider it a problem for mobile devices. So it's common to see people using integers and doubles as the go-to for whole numbers and decimal numbers. Another common data type to use is a bool or boolean. A bool is something that can hold either a true or false value. That is it. So here you can see two examples of creating a bool. We have bool m happy, we're assigning that to true, and we have bool m sad equals false. So those variables are just holding the values true or false. Now, if you're new to programming, you may be wondering what the significance of that is, And in the next class, C#102, you'll start to understand that true and false values are extremely important in programming and being able to make our programs think on their own and make decisions on their own. Another very common data type is a string. A string is basically a sequence of characters. So you can see two variables here. We have string name equals Jesse in double quotes. We use double quotes for strings to indicate that they are text and that the compiler should ignore them and just treat them as text. That's it. We have another variable called favorite color that's being assigned the value blue. And then notice down here with favorite color equals red, this is us updating the value of the variable. Notice that whenever you update the value of a variable, you do not indicate the data type again. So we're not saying string favorite color equals red because it's already declared. We can just now reuse it by using its name. And just another note, whenever you use double quotes to have a string like this is called a string literal. It basically means the string value is directly there in the code. Now, when you're dealing with strings, it's very common to want to combine strings together to build larger strings. And one way that we can do that is by using concatenation. Concatenation is basically using the plus operator. So first, take a look. We have two variables being defined. We have string first equals hello, string second equals world. And we want to combine them together in a third string and have a space in between the first two words. So as you can see, we declared a new string called combined, and the value of combined will be whatever the value of first is. So hello will be replaced with that. Then we use the plus operator, right? That's concatenation. We're saying combine the first string with this second string. Our second string is an empty quote, basically just a space operator, so that we can create a space in between the words hello and world. We have another concatenation to combine that string with the tail, which is second, and second is the value world. So if we were to print the value of this variable, we would see hello space world. Another common data type is character, C-H-A-R. A character defines a single character, like A, B, 1, 3. A single character, and we indicate a character using single quotes, not double quotes. Now, characters also have special characters. A special character is indicated by using a backslash. This is also called an escape character. And an escape character really is just an operation that is disguised in a character. So for example, \t, if you were to output that, it would insert a tab, whereas \n would go to a new line. \quote, this is an interesting one. Now you may be wondering what that's about. Well, if you think about it, since we use double quotes to indicate a string in C#, how would you actually print a quote to the screen? Because if you think about it, if I were to type a quote, the quote would be the ending quote of the opening quote of the string. So we would have a problem. So anytime you want to display an actual quote in the console or in some type of output, you escape it by using a backslash first. So these are called escape characters. Now, one thing you need to understand about a variable is, first, they are variables. They can change over time. But another thing you have to understand is that a variable can be treated as if it was its data. So anywhere you can use that data, you can use a variable. So for example, here we have a variable called age with the value 45. We have another variable called this year which is pulling out the current year by saying datetime.now.year. That's just a built-in API that we can use to retrieve the year as an integer. So we have two variables, age and this year, and then we have a third variable, which is called year born, and this is taking the values of this year, subtracting it with the value of age, and then taking that value and assigning it to the variable year born. So this means that variables can be used in the initialization or assignment of another variable. That's completely fine. And on top of that, variables can be used even in console.writeLine statements. They can be used anywhere. So in this situation, I'm trying to take the year born and display it into my console by combining the year born with you were born in. So once again, we're using concatenation to combine those two together and display them into the console. Now, using concatenation is still a very popular approach, and you'll see it from time to time. There are other techniques as well that we'll talk about throughout the remaining C# courses, but another technique for combining strings together is the replacement technique. So the biggest complaint with concatenation is that you have to close your quote to add the plus sign. So that means if you're building a very complex string, you're constantly closing quotes and opening quotes, and it can get annoying. So with the placeholder technique, we can actually never close our quotes. We can do everything in line. So for example, in this, we want to display my name is, and I am blank years old. All right, I want to display my name and age. So using the placeholder technique, we use these curly braces. So my name is, this is a placeholder right here. Open curly brace, 0, close curly brace. That is saying this is the first placeholder because in programming, we always count starting 0. So 0 is the first element. So this is our first placeholder. This is our second placeholder. Now, great, we have placeholders. Well, how do we fill values into those placeholders? Well, we do that by closing the quote at the end, adding a comma. After the first comma goes the first placeholder value. So name is going to go into that first placeholder. We do another comma. Age is the second placeholder. So if I were to run this, this would be the output. My name is Jesse, and I am 45 years old. That would be my output. Another thing that you should be aware of with C# is that C# is considered to be a type-safe language, which basically means that the compiler will ensure that we're not breaking the rules of these data types. For example, inside of an integer can only store whole numbers, right? Like 45, that is great. But we cannot store a string inside of an integer. That's because C# is a strongly typed language. Now, when it comes to naming your variables, C# is case sensitive. So these two variables right here are absolutely different variables, and even in memory, they are different locations. Even though they only differentiate by a single casing, they are completely different. Now, although this is completely fine with the C# compiler, you should always be cautious with naming. And doing different variables by just different cases tends to be a bad situation unless you're doing it in the correct situation, which we will see in future classes. Now, sticking with naming here for just a second, there are standard conventions when it comes to casing and naming of variables. The first is called camel casing. And this is where the first word in the variable is lowercase, and then all subsequent words are uppercase. We have Pascal casing, where each word, including the first, is capitalized. And you'll see that in the future, depending on the casing, it will actually tell you information about the variable. It's hard to explain now because we haven't covered some of the major topics, but by looking at a variable that's camel case, it actually says a lot about the variable, and we'll see this in the future. Now here's an example of using other conventions like all lowercase or underscores, and you can see it's not as easy to read, and it takes a second to actually see what words are being used. So another thing that we have to consider is white space, because depending on the situation you're in, white space may be important. So in the first statement, int my age equals 25 semicolon, the white space there is completely okay. In the second statement, once again, perfectly okay. Third, perfectly okay, my age equals 25, no white space. However, in the fourth statement, we run into a problem because we removed the white space in between the variable and the name. And the problem with doing that is now it can't detect what is the variable and what is the name. So it actually thinks that int my age, that whole thing is the variable name. And since there is no variable declared with that, we get an error. Now, space that is inside of a string like this, that's always okay. The more spaces you add, the more spaces you'll see if you ever output that. All right, so that now brings us to our last exercise that we're going to work on together. And in this exercise, we're going to create a basic retirement calculator. So let's go ahead and switch over back to Visual Studio, and let's create a new project. All right, so here we are back in Visual Studio. Once again, we're going to go to File, New Project. We want a console application for .NET Framework, and we're going to create our retirement app. Once again, you can place it in any location and click OK. All right, so here we are in our console application. So the goal of this application is to basically just have two users, right? We have ourselves and someone else, and then we have a retirement age. And we want to calculate when each person is going to retire and then display it into the console. So let's start creating variables. We'll start with my age, and we'll say, 25, for example. Then we'll say int your age, we'll put 35. Now we want to make a variable for the retirement age. This is a little bit tricky though, because if you think about it, the retirement age shouldn't really change that often. So if I go int retirement equals 65, I mean, that will work completely fine. But in reality, retirement is probably not going to change. So we can use another keyword called const, and this makes it constant, and basically it makes it so that it can't change. So for example, if I try to go retirement equals 50, notice how I'm getting an error. And if you look at my error list, it says the left hand side of the assignment must be a variable property or indexer. So I can't update the value of a constant. If I remove that, the error goes away. But let's leave it in, and we'll delete this. And there we go. Cool. All right, so we have retirement, my age, your age. Now let's define a message that we're going to print to the console. We're going to say string message equals, and we're going to say, will we be ready to retire soon? Question mark. Okay. Now we need to calculate when we're going to retire. So we're going to make two more variables. We'll say int years to retirement for you is equal to the retirement age minus your age. And we'll do the same for me. Int years to retirement for me equals retirement minus my age. All right, so we have both of our calculations done. Let's now display our message to the console. So we'll say to the console, we'll say console.writeLine. Let's print out that message. So into the console, it will say, will we be ready to retire soon? Then we'll do you and then me. So we'll say console.writeLine, years for you, and we'll concatenate and we'll plug in years to retirement for you. And then we'll say console.writeLine, years for me. And with this one, we'll use the placeholder technique. So remember, with the placeholder technique, we use curly braces and 0 is the first placeholder. We close the quote, then we do a comma, and then we put in the value for the replacement. So that's going to be years to retirement for me. So if we just run this application, first it compiles, and here's our answer. So will we be ready to retire soon? Years for you. So since you're 35, you have 30 years. And since I'm 25, I have 40 years. So the calculation is correct. Everything is working. However, there are a couple of things that may be confusing you. Now, you may be wondering, well, how come we made a separate variable? Could I have just putting this text directly into here? And the answer is yes. 100% you could have done that. You don't have to create a variable. We're just doing this for some practice in creating variables. Another thing you may have been wondering, well, could I have done the same thing here? Do I need to create variables here? And once again, no, technically you don't, but we're just doing it for some practice and trying to keep our code a little bit clean and easy to read. All right, so let's jump back to the slides and let's continue and finish up this video. All right, so now it's time for a flash quiz. So a flash quiz is really nothing more than just a quick question just to make sure we're understanding the material. And since this is a video recording, what you can do is I'm just going to show the question, I'll wait 1 second, and then I'll show the answer. If you want to answer these on your own, just pause the video after I show the question. So question number 1 is, can a variable change its value while the program is running? So if we think about this, remember, a variable is something that can change, right? So by definition, this answer is yes, a variable can most definitely change while the program is running. Question number 2, does white space matter in a program? So for this, remember that we looked at some of those examples of creating variables where white space mattered and where it didn't matter. So since it matters in some cases and not in others, the answer here is C, it matters sometimes. All right. So there are a few more things that I want to talk about before wrapping up. And the first thing is an expression. So simply put, an expression is something that returns or evaluates to some value. So for example, here, int sum equals 5 plus 3. 5 plus 3 is considered an expression because it evaluates to some value. Here we have a couple of interesting things going on. 5 and 3 in this second line are also expressions because, once again, they evaluate to something. 5 evaluates to 5, and so on. But another thing that's going on that's interesting is we see initialization of 2 variables, and also declaration of 2 variables. Int x equals 5, comma y equals 3 is creating 2 integers in memory and initializing them both to a value. So if you have multiple variables of the same type, you can separate them by a comma, and you don't have to keep on restating the data type itself. Sum equals x plus y. X plus y is an expression, it evaluates to something. True is an expression, it evaluates to true. And down here, this is actually a little bit confusing. Int z equals y equals 5. So what this is saying is, it's creating a new variable called z. The value of z is going to be the value of y. The value of y is going to be 5. So y becomes 5, which means z becomes 5. But one thing I want to be careful with here is that we aren't creating y. With this syntax, we aren't declaring multiple variables. We're simply assigning multiple variables. So in this case, y already has to be defined. Another area that we haven't spent too much time on are operators. So operators are basically symbols that perform some type of operation. And there's a lot when it comes to mathematical calculations. So you can see some of the common operators like plus is for addition, minus is for subtraction, and so on. We have multiplication, we have division. The percent sign is for calculating the remainder. So if you look at some of these examples over here, right, y plus x, y minus x, these are all pretty simple. The two last ones, however, are the confusing ones. So quotients is y divided by x, and the answer is 2. So y is 11, x is 5. Clearly the answer is not 2, but it is 2 in this case. We'll talk about that in a second. With the remainder, we have y percent sign x. That means basically y divided by x, and what is the remainder of that? So 5 goes into 11 2 times, and there's 1 left over. That's the remainder. So let's take a second. Let's go over why we're getting that value with the quotient. So if you look at here, here's the same example. Int x equals 5, y equals 11, z is y divided by x, and we're getting 2. The answer for that is because we are doing what's called integer division. Because x and y are declared as integers, when we divide them as integers. So even though z is a double, it's not capturing that 2.2 because 5 and 11 are integers. So it's dividing with integers and it's cutting off the decimal place. If you want to capture that decimal point, you need to declare x and y as a double as well. And then you'll see the 2.2. Here's another example of the remainder. Once again, we have 5 as x, 11 as y. So 11 mod 5 is 1 because 5 goes into 11 2 times with 1 left over. So here's just some more practice with assignments. So for example, here we start off, we have int x equals 5. Remember, variables can change over time, so this is completely valid. X equals 10 changes the value of x to 10. Now, a really good challenge for a new programmer is to think about how would you write a statement that increased the value of x by 1. So right now x is 10, how would I increase it by 1 in a statement? Now, a lot of new programmers would say things like this. Okay, well, I can do x equals 11. Although that's kind of cheating because we shouldn't know that x is 10. We want to say whatever the value of x is, increase it by 1. So sometimes people will say, okay, x equals plus 1, maybe. And no, that actually means x is equal to positive 1. So it's a little bit confusing. Try to think about it. What would I say to increase the value of x by 1? You have to fully understand the assignment operator. The assignment operator says whatever is on the right-hand side of the operator will be the value of the left-hand side. So the right-hand side could be an expression. It could be multiple things. So the answer to this question in this challenge is this. This is one way of doing it. X equals x plus 1. So what this says is the new value of x is going to be whatever's on the right-hand side. So we're saying, okay, the right-hand side is the current value of x, so that's 10, plus 1. 10 plus 1 is 11, now x is 11. So with this formula, no matter what the previous value of x was, it will always increase by 1. And we could do similar things with multiplication with any operator. This is how you just do an operation to itself. Now, there's a common stereotype that programmers are lazy and that we don't like to type. So it turns out that instead of writing x equals x plus 1, because if you think about it, we are duplicating our keystrokes. We have to type x twice. There's actually a shorthand for it, and that is this right here, x plus equal 1. This is called a compound assignment, where we combine plus and equal, or minus and equal, or times. It doesn't matter what operator it is. We can combine them with an equal sign, and that basically means the same as x equals x plus 1 or x plus equals 1. It says take whatever the value of x is and add 1 to it or subtract 1 to it. Whatever it is, it doesn't matter. So that's another technique. And finally, there's even a third technique for increasing by 1. So we had these operators. These are the first ones. These are called prefix operators. We have plus, plus, and minus, minus for increment and decrement. So if you look at this code, it's a little bit confusing. So let's step through it together. So we have int x equals 5, y equals 0, z equals 0. So y equals plus plus x. So x is 5 originally. By saying plus plus x, plus plus means increase x by 1. That's what it means. So now what we're saying is, okay, plus plus x, x goes up by 1, and then we assign. So in this case, y is equal to plus plus x. Y is equal to 6, and also x goes up by 1. So with the prefix operator, it first increments, then assigns. So it increments the variable and then assigns it. Same thing with subtraction. Minus minus y would subtract 1 and then assign. Now this is different than doing what's called the postfix operator. The postfix operator, as you can see here, the plus plus and minus minus comes after. So it's a different order. In this order, I'm saying y equals x. So right away, y equals x. Whatever x is, y is now the value of that. So x is 5, so y is now 5. And then after the assignment, x increases by 1, which makes x 6 and y 5. Right? We read from left to right. So since we hit the x first, we do the assignment, then the increment. Whereas with prefix, we hit the increment first, so we increment, then assign. And this works with minus, minus. It's the same idea. Now, finally, the last operator I want to show you are some comparison operators. And this is kind of a tease for CSC102 because in CSC102, that's where we're going to really start asking the computer questions. And if you look at these operators, these all return true or false, right? If I asked you, is 5 greater than 6? There's only 2 possible answers, yes or no, or true or false. So these operators are going to become really important when we're starting to ask the computer questions because we can get back yes and no answers. So we have greater than or equal to, less than or equal to. 2 equal signs, this one's a little bit confusing. This is a comparison. We're saying, hey, is y equal to z? We're not assigning a value, we're checking to see if they are equal. And there's actually even one more operator. It's exclamation point equal, and that means not equal to. So it's the opposite of equals to. And we'll see that in future courses as well. All right, so let's do one more flash quiz to wrap up this course. So question number 1, in the following code, what is the value of z? So for this one, you have to remember that since x and y are integers, we're doing integer division. So we're not going to get a remainder, we're not going to get a decimal. The answer here is 3 because 3 goes into 10 3 times. Question number 2. In this following code fragment, what is the value of z? Alright, so for this one, you had to remember that the percent sign is the remainder operator. So the answer here is y is 10, x is 3. 3 goes into 10 3 times with 1 left over. So the answer is D1. Awesome. Alright, so in this last section, we looked at the basics of C#. We looked at some statements, we looked at how we can create variables using data types, and we also looked at some strings and white space. So in the next video, which is C#102, we're going to start talking about making decisions, and we'll look at concepts like branching and looping to make our programs think on their own and make decisions on their own and perform different actions based off of those decisions. Alright, so that brings us to the end of the course for today. I want to say thank you for taking the time for watching this video. And I really do recommend that you continue taking the C# classes and head over to C# 102. Once again, thank you and enjoy the rest of your day.